Now. Hello, everyone. My name is Molly Halsey, and I'm the event specialist here at EDB. I will be your host today for our webinar, PostgreSQL as a Strategic Tool. I'm joined today by Mark Linster, our Chief Technology Officer. Before we get started, I'm going to go through just a few housekeeping items. We can hit that next slide. So this presentation is being recorded. We will be sharing the recording along with the slides after the broadcast. The lines are currently muted. If you have a question, please feel free to submit it in the Q&A panel. Today's session is scheduled for 1 hour. We expect the presentation to last most of our time, and we will allot any extra time for Q&A. If we do not have time to address all the questions, we will follow up afterwards with any attendee whose question was not answered. Now, without further ado, I'll give it over to Mark.
All right, thank you, Molly. Thank you. Okay, so what we're going to do today is maybe a little bit of a less technical webinar than others that I've given in the past. Today we'll talk mostly about practices that I have seen personally with leaders adopting Postgres, meaning how are they going about that? How's a chief data officer? How's a CIO? How's a VP of data management going about driving the adoption of Postgres, right? What are the kind of like tips and tricks outside of the pure technology? That's what we're going to talk about today. So we'll spend a good bit of time on that, and as Molly said, hopefully we'll have some time for Q&A at the end of the presentation. I'll be very brief about who's EDB. Promise won't take more than a few minutes, and then we'll dive into sharing some experience and expertise that I've gathered working with EDB and Postgres over the last now almost 8 years. Okay, so let me dive into this very quickly. Who's EDB? Well, what we pride ourselves on is our job is to supercharge PostgreSQL. We're not the only ones working on PostgreSQL, but we're the largest provider of open source based PostgreSQL software, and we're over 4,000 customers today. We've been in the business now for 16 years, over 400 employees, and we're a big player in the Postgres community. Postgres community is very diverse. There's lots of companies in it. We're by far not like the dominant company or something, but we're playing a big role in this. And we've offices in 16 locations around the world. Our headquarters is in Boston. So let me outline a little bit the type of expertise that we're bringing to the table. And it's important in the context of today's presentation because, I want you to understand why we're saying some of the things that we're saying and where that experience is coming from. We're very well positioned to make these kinds of statements just because we've been with major customers and with Postgres for such a long time. Been founded in 2004. Some of our team members, such as Bruce Momsen, for example, have been with Postgres much, much longer, actually since the birth of the PostgreSQL open source community. And Mike Stonebreaker, the initial creator of Postgres, who designed Postgres in the second half of the 80s, is an advisor to our company today. So we're really steeped into that stuff. At the same time, you can look at Gartner's Magic Quadrant, and we are, and we have been for the last 7 years in the Magic Quadrant for operational relational database management systems. And so that means that an expert like Gartner, after having interviewed quite a few of our customers, recognizes that, yeah, we have the ability to execute, and we have the vision that is needed to actually be a global player to our customers. And one thing that I want to really point out here is, well, it's remarkable because of what you don't see. There's no other open source relational database management system in this Magic Quadrant, only EDB Postgres. Okay, so in that time, we have contributed significantly to PostgreSQL and to EDB Postgres Advanced Server. PostgreSQL is obviously the open source version under a PostgreSQL license, and EDB Postgres Advanced Server is our proprietary software. So we're doing a little bit of the work on both sides, always depending on, what's the best place to add a new feature. For example, the Postgres community is probably less interested in syntactical compatibility with Oracle. Many of our customers, however, are interested in that because they want to migrate off of Oracle. So we do a lot of work on the PostgreSQL open source side, such as here early on, heap-only tuples or HOTs, materialized views, the work on parallel query that Robert Haas has been doing, the work on just-in-time compilation, the work that's has been going on serializable parallel query, or just even now in PostgreSQL 13, the work on parallel vacuum for indexing. So we do a lot of work on that side, while we also work on proprietary additions, such as Oracle compatibility, a different way to do auditing, much more detailed auditing, other security mechanisms, etc. So we've been in this business for quite a while, and with over 4,000 customers and a lot of contributions to Postgres, I think we can pride ourselves in really understanding the tech and the market. I'm not going to go through this eye chart here, but it's going to be part of the follow-up that Molly will send down, where you can see which things we've been adding to EDB Postgres Advanced Server, our proprietary version, and then what we have been contributing or participating with in the PostgreSQL core database. So we're very connected to the community. Obviously, we couldn't do all this work in PostgreSQL if we were not connected to the community. So we're active in the core team. Now, the core team is a team of people who, behind the scenes, make sure that everything in the community is working right, and the processes are working right, etc. So we're active in there with people like Bruce and Dave Page. But then we also have major contributors and other named contributors. Major contributors, some of you may know, like Robert Haas, who's been, are driving architecture in Postgres for quite a few years, or Devon Gunduz. If you've been using any RPMs for Postgres that you downloaded from PostgreSQL.org, it was always Devon who's involved in making sure that that is happening. So a lot of this work EDB does behind the scenes, but we've been, with Postgres for quite a long time. And then we're also active in other adjacent projects like pgadmin, which is where Akshay Joshi is a major contributor, and Ashish Vashi at the same time, and Dave Page. Okay, so yeah, we're very active on the commercial side, obviously with over 4,000 customers, but a lot of our work and energy goes into open source Postgres. So what do? Well, we provide multiple different or two different database packages, right? PostgreSQL, the open source version, and EDB Postgres Advanced Server, the proprietary version with Oracle and Oracle compatibility. And then we provide a number of tools, and I won't go into them a whole lot here, but important is they are intended to give you high availability with very, very fast recognition of failures and very fast switchover. Management at scale, a little bit like Oracle Enterprise Manager if you come from Oracle. Integration and replication tools, a little bit like Golden Gate. So there's a complete portfolio that we are providing, and then the right support and services, etc. So I won't talk any more about EDB. Hopefully it gives you a bit of an impression as to why I feel comfortable making quite assertive statements about what it takes to be successful with Postgres. So what's the challenge that we're trying to address here? Why am I doing this presentation? Why do we have this webinar? The question is, how do you get the most mileage out of what I consider the best open source relational database? How do you do it? Right? How do leaders do it? I mean, you can consult our list of customers, and you can kind of figure out who I think those leaders are, because there's very large credit card companies, large financial institutions, large insurances, etc. They're all part of our customer roster. So we've observed them and we've advised them on how to do it. And what I'm going to do here is share a little bit what I would call the best practices or proven practices as to how to go about it. So if I summarize that, and some of this may sound trivial, but it's extremely important to avoid missteps and mistakes. First, you need to understand the application landscape and be clear about the fit for Postgres. And Postgres is a great database, but can it do everything? Well, yeah, it's a Turing machine, so theoretically it could do everything. But is it always, I mean, should you use Postgres for everything? Well, I actually don't think so. You should know exactly where it shines and then focus on that. And then, think about how do you do this? A lot of people come to us and say, hey, I have 1,000 databases. Or I actually had one customer who came to us and said, I have 10,000 databases and I'm going to go open source. So Mark, what do we do? How do we start? Where do we start? So the question is, how do we eat this elephant? Well, it's actually one bite at a time, and I'll give you some ideas as to, how customers have tackled that problem. And then, how do you drive adoption? How do you get going? How do you get going in an environment where potentially people have been with Oracle or SQL Server for 5 or 10 or 15 years, or DB2, right? And they know it works. They may not always be happy, but they know it works. They know what to do to stop the phone from ringing on the weekend. They know what it takes to bring an application or a database implementation to success. Okay? So we'll go through that a little bit as to some tricks of the trade that we've learned as to how to do that. And then, a big pet peeve of mine is standardization and automation. Standardization and automation. I think it's even more important with open source tools, not just Postgres, but open source in general, than that was in the past with proprietary tools. Okay, so let's just kind of open this up a little bit. Everybody's saying, hey, open source is winning, right? Gartner says it. Gartner said for years that this is happening and everybody should go there. And I think, people are going there. When I started in Postgres 8 years ago, we were evangelizing for Postgres. We're no longer evangelizing for Postgres. Well, not really. We're evangelizing for, helping people to figure out how to use Postgres for absolutely mission-critical things and how to get going with it. But almost every company that I talk to today has Postgres somewhere. Sometimes it's just niches, and they don't know how to get out of those niches, how to really get business value out of it, and that's what we're going to talk about here. But Postgres is now all over the place, but still, in order to be successful, you should really know where it's good, where it shines, right? We're seeing other things like, the standard message that Postgres has won, and that indeed is true. If you look at surveys, developer surveys, etc., it is like the second most used, the second most loved database. So definitely, Postgres is it today. It's all over the place, and it's no longer the situation that we had a few years ago where you need to convince people that they should consider Postgres. Now it's really how to be successful with Postgres. So even in containers, second most popular container image based on the Datadog survey, right after Nginx, which again makes good sense, right? But again, it's far ahead of others like Elastic, Mongo, or MySQL, okay, in those types of environments. But again, should it always be used? Well, personally, I don't think so. Because there are areas where it's really strong, and there's areas where, it can be used, but it's maybe shouldn't be the first choice. Like, if we look at this panoply of application possibilities here, taking us all the way from a data lake to, the data warehouse, data mart, the ODS, right, the operational data store, the system of records, so kind of like the ERP, CRM type systems, the systems of engagement, more like, website, social media type of things, to then edge computing and then mobile computing. Well, if you really look at where Postgres is good and very, very successful, it is that center space. Data warehousing, data lake. Yeah, there are some Postgres implementations, but it's really not what Postgres is strong at. If you have, 50, 100 terabytes of data or even more, that really stretches Postgres. There are experts who know how to do it. but it is not one of the strengths of Postgres. It's also not, it doesn't have the capabilities that you would like to have, like automatically refreshing materialized views, for example. It doesn't have that. So yes, you can refresh the materialized view concurrently, but it doesn't happen all the time. So it's a little weaker there than other products, right? But if you look at the core where it's really strong, data mart, ODS, system of record, system of engagement, and edge computing, it's really, really good. I mean, we did a survey 2 years ago of our customers, and 60% of our customers used it for data mart or ODS type applications. They also use it for system of record. Over 50% said they use it there. But there's a significant overlap. The reason being that Postgres has developed quite strong analytical capabilities, such as, you know, as I said, the concurrently refreshing materialized views, but not automatically refreshing materialized views. It has now developed cube set rollup capabilities. It can do parallel query. It can do just-in-time compilation. So it's a solid player today in data mart and ODS. Okay? It is absolutely well known and I think really, really strong in the system of record space, right? Where, you know, it's very innovative with JSON and PostGIS and HStore and the data types, the extensions, etc. It's very innovative, it's very cost effective, and you know, the speed is really, really good. Systems of engagement, so like websites, social media sites, etc. It's very, very interesting in that space, right? I mean, now you can have it containerized, and it works well in containers. You can deploy it everywhere, not just virtually everywhere, but actually everywhere, right? I have another presentation where we go out about where we talk about Postgres in multiple clouds, and Postgres today is available everywhere, as in many clouds as a managed service, in many clouds as a service, as a software that you can deploy yourself, and you have multiple vendors to actually support you with it. So for systems of engagement, it's ideal because you can just shift it around. You're not tied to a certain license model. You're not tied to a certain deployment model. That's really where it's very, very strong. And then also because of its PostGIS capability, its JSON-B capability, the HStore capability, those make it really, really interesting for social media or edge computing type of environments, right? So those are the areas where we know that it's very strong. If you try to put it into a mobile device, would it work? Yeah, but you know, in a mobile device, you actually don't have multiple users. You don't have concurrency. So, you know, SQLite might be the better solution because you only have a single user on the mobile device. So, you know, why worry about locking and all that kind of stuff, right? So, so that's why typically we don't find Postgres on mobile devices. But I mean, you can run it there. It's not a problem. It does run on Arduino. It really doesn't have a lot of resource need, but you know, it's not really what it was designed for. Okay, so this is the first thing that I think everybody needs to understand. Where does Postgres shine? Okay, now you may say, hey, in my company, we have 10,000 databases. And Mark, yeah, you just cut off the data warehouse. We were thinking about a data lake, but you know, that's not really. So maybe we're down to 9,995 databases now. Okay, so how do we handle those? How do we tackle those? Where do we start? How do we eat this elephant? Well, you know, it's really important to do it one bite at a time. There's a temptation to go for major impact and address the worst legacy problems first. I think that's, while it's tempting, that tends to be a mistake because you're going after the biggest problems first, and that tends to be kind of very, very difficult to do. The recipe for success that we've seen is tier your applications. And many companies have tiering models, and we'll go through one model that I've developed together with my colleague Vibor Kumar for one of our customers. But do the tiering so you can figure out what's an accessible target and a target that is worth it, right? And then because of the tiering, you can start developing reference architectures. And then you understand your maturity, your ability to actually deploy and support those reference architectures, okay? And then find the right basis between feasible and meaningful. Because obviously, when you deploy it, you want to make sure that it's a success, that you can talk about the success, and that others adopt, that it drives a groundswell and excitement for Postgres and open source. So here's a sample tiering framework. And I'm not saying, please, that this is the tiering framework. This is a sample, right? I mean, we've had many customers who just have tier 1, tier 2, tier 3. That's all they have. Others have a more complex model, right? And it all depends. You need to understand that. And I'm working with customers personally around metrics like RPO, RTO, GRO, right? Recovery point objective, recovery time objective, geographic recovery objective, and then, you know, in terms of TPS and numbers of users. And I know that, and database size. And I know that those are not that meaningful because, you know, a transaction is not equal a transaction, right? It can be a TPCC type transaction, a TPCB type transaction, TPCH type transaction, and they're all very, very different animals. But somehow conceptually, you need to overlay a framework onto your universe to start organizing these things. And basically what happens then is you'll see, I believe, that, for example, departmental applications that are not mission critical, that have an allowable downtime of, let's say, 24 hours, they will probably share architectural commonalities. Most likely, they will be single server systems. The servers will be server class systems, so dual network, dual power supply, racked, all that kind of stuff. But do you really need high availability? Do you need an off-site replica? Probably not. Do you need connection pooling? Well, maybe, but I'm not sure. And then you go to departmental mission critical. Well, now at that point in time, your SLA has gotten higher. So now you will start thinking about, okay, do I have on-site read replicas? Do I need automatic error detection and failover? For an SLA of 4 nines, I would say definitely you do need it, okay? Your transaction rates are going to go up. So maybe at that point in time, you're going to go from a single mount point to 2 or 3 different mount points for data, for wall, and for logging, okay? And as we go up this tiering, there will be other common things that are showing up, like connection poolers, connection routers, the use of, I don't know, an F5 big IP infrastructure, that kind of stuff will start showing up. So this is one way of organizing your 10,000 databases and finding and classifying them. And then you tackle one of those classes at a time. Right? The reason why you tackle one of those classes at a time is because they have commonality. They have commonality in architecture, they have commonality in support practices, in integration practices, in integration with your backup, integration with your authentication, etc. They will have similarities, at least in most companies, they will have similarities. So that will allow you to develop a reference architecture and train your team on how to use it, train your team on how to support it, train your team on how to actually achieve these SLAs without being called out of bed on the weekend, right? So on the one side, as I said, understanding where Postgres is strong, and on the other side, understanding your application landscape, and then, you know, I do that through tiering, mostly along mission criticality, and then digging a little deeper into things like RPO, RTO, GRO, which are sort of, you know, the components of SLA, at least in my world they are. And then we look at things like maintenance windows, etc. Right? So there's a good bit of understanding that you need to do, and then you can really laser in on where you will use Postgres. Okay. So once we've done the tiering, now we can develop reference architectures for those tiers. And you can go to our website. Dave Page, my colleague Dave Page, just last week, or actually this week, published a blog on reference architectures, right? And it links to a GitHub repo of reference architectures for different types of use cases and different requirements. So a reference architecture really looks at, okay, what do I need in compute and storage? Okay, how is my high availability structure laid out? Meaning, do I have, is it just local, like in my DC, I might have no replica, I might have a local replica, or do I have a metro area network where maybe I have another data center across the street? So we're on a fiber network, we're very, very fast. It's almost like no distance. So, you know, I can do things potentially like synchronous replication, or is it a geo-distributed model, or is it actually local with geo-distributed, so that I have a local synchronous replica and a geo-distributed asynchronous replica just to protect me from major disasters. Right? We work with a lot of financial institutions, and that's a model that they use a lot. So that in case of a major issue, like a whole data center being flattened, there is still a redundant copy. That redundant copy may suffer from some RPO, but you know, most of the data is still there. So that, again, that's a characteristic of a certain type of reference architecture. Look at, you know, what you do for replication. Do you do streaming replication, logical replication, or both? Right? There's pros and cons to this mix, and again, it depends on the use case. Do you need connection pool, query routing, or do you need both? It all depends on, you know, what class of applications we're looking at. Right? If we're looking at moving legacy applications to Postgres, very often those only have a single connection pool. Well, if you have a single connection pool, but you still want to take advantage of read replicas, you can use query routing. So the standard tool in Postgres for that is pgpool. It inspects every query and then decides whether this is a read-only query or it is something that needs to be sent to the primary. And then, as I said, understand SLA, RPO, RTO, GRO, become comfortable with that, and then you pick a reference architecture for every class of system that you want to move. And we'll come back to the need for the reference architectures a little bit later and why they are such an important tool for success. You need to understand where you are on the
you wanted to launch?
Excuse me?
Was there a poll that you wanted to launch?
Oh, I'm sorry. Very sorry. Where was I supposed to have the poll? Here, right? Oh, yeah.
Right at slide 18.
Good. So,
yeah.
I am on slide 18 now? Or? Okay, thank you. Thank you very much. Thank you very much.
Sorry to interrupt you with that. I'll hit
That's
launch
very good
right
of you.
now.
Thank you.
So the poll we have first is, where are you in the Postgres journey? Your options are: we have not started with Postgres, we're in the emerging stage, we're in the expanding stage, or we're in the strategic stage. So we'll give everyone just a bit of time to answer. Already within 20 seconds, almost 30% of the audience has voted. We're gonna have a lot of different answers today. We're already at 50%. I'll give it another 5 more seconds before I show the results. All right, here they are.
Okay, all right, good. That's very interesting, and thank you again, Molly, for interrupting me. As you and the audience can tell, I can kind of get animated about this topic, so I would have blown right past the need for this poll. So let me just comment on this a little bit. This is interesting. This is actually a little stronger than what we see with many of our customers, right? I mean, we're seeing Postgres become strategic. We have a number of customers that have declared, and they're very large customers, so very large companies and large customers of ours who have declared that if you're not using Postgres, you have to explain why. And all of those that I'm aware of used to have that exact statement for Oracle. So Oracle was the standard. If you wanted to use anything but Oracle, you had to explain why. Now they've shifted to a model where Postgres is the standard, and if you want to use anything else, then you have to explain why you're not using the standard. So that's very interesting. And the emerging and expanding stage, there's a lot of work that that can be done there. I think when we look at this journey that I'm showing here, is we see a lot of companies getting into the emerging stage usually because of a single project, or sometimes because of an acquisition. And then suddenly they're stuck with Postgres. And what happens then, and this happened more than once, is one or two DBAs or senior DBAs, experienced folks, actually have to work with this. They start to work with this, and then they start liking it, and they become evangelists, and they become, they really develop almost like a missionary zeal and convince others that, hey, this is actually pretty good stuff. It's creative, it's innovative, and you don't get fired for using Postgres. You can actually do a lot of stuff that with commercial databases took a long, long time, because the tooling is pretty good in Postgres, the features are pretty good, and that's how we often get from emerging to expanding. We have other models where the CIO or the CTO says, hey, we're going Postgres because we're going open source. We need to free up some cash. We need greater flexibility. We need to change the culture. And we'll talk a little bit about, how that's being enabled, because you still need to get people excited about it. If you have a team that says, no, I don't want to get off Oracle. I know how to do Oracle, and that's what I'm going to do. Then that's very difficult. So creating the excitement, doing evangelizing, doing meetups, doing all those things. I'll talk about that a little bit. But that's a really important tool to move it from emerging to expanding and finally to strategic. Because once you get to strategic, then you have a significant knowledge base in the company. You have a culture for this kind of stuff. You have a culture that enables agility, eventually DevOps, and hopefully helps you break through the barriers between, let's say, the application development teams and the DBA teams, barriers that we're often observing. Okay, so let me go forward here. I talked about collaboration and evangelizing already a little bit. And you may think, hey, that's a strange thing. Why does a techie talk about that? Well, what I'm observing often is that the DBA teams and the development teams, they don't talk. And I've had quotes like, I don't need no effing DBA. I don't need them, right? I don't want to. And then when I dug in, I found out that the development teams and DBA teams were so at arm's length that if a developer, if they wanted to have an additional column or change the length of the last name column from 25 to 29 characters, they had to file a ticket, and it could take, 5 to 15 days to get its simple change done. So that's obviously a problem if you're supposed to be agile, move fast, meet deadlines, etc. So that's obviously something that causes a lot of friction. And so what we need to do is we need to make sure that we can break through those barriers. The barriers appear on both sides. I've had customers where the DBA team said, oh yeah, we can support Postgres, but nobody's using it. So it was a waste. Well, obviously that needs to be fixed, right? And then we have other situations where the development team says, oh yeah, we'd love to develop on Postgres, it's great, but the DBA teams don't know how to support it. Again, that's something that needs to be fixed, and those walls need to be broken through. And Bruce Mongen and I, we do a lot of this work in evangelizing, and the only way to do this is to create a bottom-up innovation movement where, support informal discussions. Do it with us or without us, it doesn't matter. Do lunch and learns, do hackathons, encourage meetups. There's a thing that goes with open source that is not just that the license is open, but it's an open collaboration environment where a lot more sharing happens. The code is open, but also the plans are open. And that openness encourages a DevOps culture that breaks down the walls between developers and DBAs, bring them together onto one team with shared responsibilities and not at arm's length. And please, if you can, get rid of systems where developers need to file a ticket to get a column defined in the database. That absolutely forces developers to use Mongo, or other environments for the sole reason that they don't need to file a ticket to get a column created, right? They can just say add to collection and they're done. At the end of the day, many people will be unhappy with the results because there's no foreign keys, there's no efficiencies, there's no indexes, etc. But the culture actually forced the design decision. So that's really a key thing that we need to break down those walls, because otherwise we don't get the mileage out of Postgres. Okay. We need to enable. We need to make sure that DBAs are ready to support production. Developing in Postgres is really easy. Supporting Postgres is not hard, but it's a little bit different from Oracle. There's a couple of things like vacuum and bloat and how failover works and how backup and recovery works and how tuning works that are different. Not tremendously different, but different enough that if you're not ready to handle them, you'll get in trouble. Look at remote DBA services to help you over that, so that you have an outside partner who works with you. And then last thing, I'll get back to that, is invest in automation to be responsive. There's one thing that happens when you move to open source in a company is the speed of innovation. Innovation accelerates tremendously. The demands on the infrastructure accelerate. The time windows to create a new database go down. And the only way I know how to handle that is with reference architectures and automation. So it becomes very easy to say to somebody, what do you need? And they can say, I need a tier 2, class 3 application, which would be their lingo for saying, I need to develop a departmental mission critical app, and I need it to be of a certain machine type. And once you can speak that language, everybody knows what they want. And now you can start using Ansible and or Terraform or something like that to create those things rapidly and to meet that demand in a matter of like hours, and not the way it was and still is in many companies where provisioning a new database takes weeks. In that case, when it takes weeks, the development team has no choice but to go to Amazon and do something there, right? So standardization, automation is absolutely important. Okay, so I'll get into that because, that's a bit of a pet peeve of mine. Open source will drive agility. Agility, in this case, really means speed and scale, right? So you're going to be in an environment where provisioning and deprovisioning databases happens on a daily basis. It's not a big thing. I was a CIO a while ago. I was a development leader a while ago, and in those times, provisioning a new database was like not exactly an act of God, but it was a big deal, and it took a long time. And that can't be anymore, because in the world of open source and the world of agile development and the world of DevOps, those things need to happen quickly. And there is no scalability without automation. You're not going to be able to go from create one database a week to creating 2 databases a day to creating 2 databases an hour without automation. And automation does not work without standardization. Right? If you can't standardize, if you cannot say, hey, I have a certain class of app that's fully automated, or you want one of them, let me click the button, I'll get it to you, I'll register it in the asset management database, and we're all set and ready to support you. If you can't do that, then your Postgres endeavor is not going to be as successful as it could be. So when we talk about Postgres deployment automation, again, these slides are from a presentation that my colleague Kanchan Rohiti and Vibhor Kumar gave at Postgres Vision, so you can look up all the details there. But there's a lot of different technologies that you can look at. There's the most well-known ones are Terraform, from HashiCorp, CloudFormation on Amazon, and then Ansible, Chef, Puppet, and Salt to actually lay down the software. Things that you need to consider are, what do you really want to do? Just provision? Do you want to manage? Do you want to be procedural versus declarative? Do you want to manage a state, or do you just want to automate some actions? Those are all things that you need to be aware of, right? Are you looking at mutable infrastructure, so where you manage a state, or mutable infrastructure where you manage actions, or immutable infrastructure where you manage a state? And again, that will help you figure out whether, for example, it's Salt, which is more state management based, or Ansible, which is more, action based. Okay? We did a survey on the download site for
Mark, I'm sorry to interrupt
Postgres
you
installer
again.
for Windows. Yeah. Oh yeah. Hold me. Let me just finish this, and then we'll do the survey.
Great.
So what we did on that survey was we asked about 1,200 people who came to our site, what are they using for deployment, right? And you can see here clearly that Ansible and Terraform were the clear winners. Now, I must say this survey was done on a Windows download site, so that's a good reason why you will not see cloud formations, right? Because that's more of an Amazon type of thing. Okay. So now, Molly, let's go into the survey.
Yes. All right. So the poll is: do you use automation to deploy Postgres? This is a multiple choice question. So if you use more than one of these, you can answer more than once. The options are no, we don't use automation, Bash scripts, Ansible, Chef, Puppet, Terraform, Salt, CloudFormation, or other if you use something that is not listed. So we'll give everyone a bit of time. Everyone has answered incredibly fast, literally over 50% of the audience already. I'll give it another 5 seconds before I show the results. Give anyone who didn't get an answer time to. And here are.
Oops. Can you bring that up again, please?
Yes.
Okay, thank you. All right, good. This is not a surprise. I would have expected Salt to be a little higher. I mean, Salt's a state-based system. Our IT department uses Salt, for example, a lot to manage state, because Salt's a little different from, let's say, Ansible, because Salt, where you publish the target state and then the system figures out how to get there. Chef and Puppet, hey, 0 for Chef. That is surprising. Puppet's a little older, but still with 14%, it's well represented. And for those that don't use automation, I would seriously suggest start looking into it, because it'll make your life a lot easier, right? When we in the context of containers, we often talk about cattle versus pets. Well, the same thing sort of applies here a little bit, that traditionally we used to treat databases like exotic pets. Every single database was different. Everything was tuned a little differently. But if we start rolling out applications faster and faster and faster, then standardization and automation really become very, very important. Also in environments where high security, always high, having current patching levels, et cetera, is important. Considering automation is key. All right, thanks very much. Thank you. And we'll share all this data with the audience at the end. Obviously not who responded to what, but the summaries of the stats, we'll share those with you. So one way, if you're thinking about automation, Ansible Galaxy is the place where Ansible publishes what's called rules, right? And Ansible uses a concept of playbooks and rules. So rules are standard things, like in this case here we have a rule that's called install DB server, or initialize the database server, set up EFM. EFM is our high availability tool, etc. So those are standard roles, and then you write a playbook that orchestrates how those roles play together to create a more complex installation. I'm pointing this out because everything on Ansible Galaxy is published under open source license. So if you want to get some inspiration for how to do this, or figure out, hey, are there high-level building blocks that you can use, take a look at this. Just go to Ansible Galaxy and actually search for Postgres. You'll see that the EDB Postgres scripts, at least as of a couple of days ago, were on the top of that list, and they have a very, very high score, very, very good rating for it. So that will hopefully get you started. by me emphasizing Ansible, I don't want to say anything negative about Chef, Puppet, Salt, or any of the other scripting languages. It is just something that that we're pushing forward with. But that's you know, there's lots of reasons to make the different choices, and hopefully on the slide where I showed all the different automation scripts, I gave you a bit of an idea for what the questions are that you should ask. Okay, so in summary, the recommended practices is understand the application landscape and the fit for Postgres. Be honest about that. Don't try to use Postgres for everything. Postgres is a very, very good tool, but just like in the world of cars, right? If you know, it's a good reason why there's race cars and pickup trucks and family cars and four-wheel drive cars, etc. Because you know there's a fit for purpose, and really understanding the fit for purpose is important because you do want to be successful. Eating the elephant, I'm saying here, do it one bite at a time. My recommendation is create a tiering structure, and inside that tiering structure, create standard architectures that you then deploy multiple times so that you learn how to work with them, how to support them, how to use them, how to tune them, because at the end of the day, that's going to be absolutely important to your success. And then another piece of advice here, don't start with the most difficult thing, even though maybe the CIO really wants that thing to be gone. I've not seen heroic attempts like that succeed at the first go, right? Cut your teeth on something that is more mid-level. Be successful with that. Learn how to manage Postgres in production so that the phone doesn't ring on the weekend, and then you tackle, you know, the big monster that, you know, the organization maybe inherited from 20 years ago. Foster collaboration. You need to drive adoption, and I think one of the keys for success with Postgres is to bring the developers and the DBAs together to figure out the best possible solution, because Postgres has a whole bag of tricks that makes development much, much more effective and efficient. The whole thing around GIS, the data types, the extension, HStore, key value pairs, and JSONB for documents, those things need to be understood and leveraged. And the best way to do that is in collaboration with the DBA team. Okay, and then, you know, my pet peeve, use standardization because it enables automation. It'll make you much more agile and much, much faster. So there's a bunch of resources, and Molly, can you post those in the chat?
Yes, I just dropped
the exact
them. So
links,
for anyone
please.
looking for them.
Okay, good. Okay, so the exact links are in the chat, and they will be in the presentation when we send it out. So there's a longer article that goes with this talk. Then Dave Page published a whole set of reference architectures. Doesn't mean that that's the only ones, but that's a possible starting point. And then there's also the pointer to the Ansible Galaxy Postgres roles. Okay, so we got 10 minutes for questions.
Yeah.
Molly, what do you got?
So we got some great questions today, very deep. I'll try to start a little bit lighter today. One of the first questions that came in was asking if you could compare and contrast Postgres with SAP HANA's in-memory database, and where does Postgres shine there?
Okay, well, Postgres is not an in-memory database. It doesn't. That's one thing that Postgres does not have, right? So that's one of the reasons why, for example, in very large combined data warehouse and system of reference applications, or something that Gartner calls HTAP, hybrid transactional and analytical processing applications, that is in large deployments like what HANA is for. That's one of the areas Postgres does not shine. And you know, if you work with us or with me or my team, we'll be the first ones to tell you that, because we don't want you to lead into areas where, you know, Postgres is not really good. And understanding fit for purpose is very important. So HANA has very strong in-memory capabilities. Postgres does not have that. So if you really need those, if you really need to have, you know, terabytes in memory to do the work, then Postgres is not the right choice. That's not a fit for purpose.
Okay. Great to know. Always being very transparent, very important. Another question that we had was, how does PostgreSQL fit with the concept of product teams, where database management functions are distributed out to product teams that manage the entire development and support lifecycle of an application, including the database? That's a
I
big
love
one.
that. I love that. You know, we have a number of customers who've decided strategically that they will tell their developers to develop to the libpq API. And because then it's ultimately portable and they can create a base of knowledge across all teams, how to deploy it, how to manage it, how to make that happen. So I think a product team like that, where you're breaking up the walls that often exist between development and DBA is great. I assume you still have a community of practice or some other organizational model that brings the DBAs together for career development, for for learning, for practices, etc. But you put them into the development team so that they closely collaborate. That's, in my view, that's an absolute must-have if you want to be successful with DevOps and get mileage from the database. Right? There's a very good recent book by Dimitri Fontaine, The Art of Postgres, and in there he has a whole section that describes the awful things that can happen if DBA and developer does not work closely together. Because what happens then, what tends to happen, I'm not shouldn't generalize, but what tends to happen is that the developer will try to suck up all the data into the application to do their logic there, and then kind of write the result back into the database. Sounds, for the developers probably sounds logical. That's not that hard. We just, put it into an array or, into some kind of a bitmap or a hash or whatever, and then we do our processing and push it right back. Well, for the DBA, they probably just heard a horror story because you just left the isolation levels. You jumped out of ACID, right, to do your calculation, and then you commit your result into your outside of the transactional world. Those things can only be avoided if the expertise of development and data management actually come together. So I love that. Sorry, that was long.
No, great answer. So we had another anonymous question coming in about migration, and they're wondering, they're planning on migrating to Postgres from SQL Server. Are there any tools that can help with the migration? And does Postgres have DMV like SQL Server to tune and understand database system metadata?
Well, okay, so there's a couple of questions in there. So EDB has a tool called MTK, Migration Toolkit, that will help you move the data structures and the data from SQL Server. So that's for the initial snapshot. And then we have a tool that's called Replication Server that is a CDC type change data capture mechanism. Because what happens if you just try to do a snapshot migration, that's okay for small databases. If you have, hundreds of megabytes or even hundreds of gigabytes, that's most of the time going to work okay because you can get enough downtime to basically dump the database to disk in some kind of a text format and then reload it into Postgres. So if you have a couple of gigs or even 100 gig or something, that can happen in a very short time. But if you get into larger databases, like terabytes or so, then you need to start thinking about like 24 hours per terabyte to do something like that, if not more. So now the outage windows become a real problem. And that's when you need change data capture, so you can do a snapshot and then do ongoing change data capture until your replica has caught up, and then you can cut over. The second question is, it's a little different. You would use Postgres Enterprise Manager, for example, to do the tuning and understand how the database itself performs, and that would be the right tooling. So those kinds of changes to understand what is the tool that you would use to achieve certain things, that's usually where training and and working with somebody who's done similar migrations is important, because the migration in this case is not just about how do I get the code and the data there, but also how do I migrate my practices, right? So that you know this procedure is what I usually did on, I don't know, Friday evening to review the week and find any exceptions. This is how I do that similar procedure on Postgres that I used to do on SQL Server.
Okay, great. So I think we have time for just one more question. And this question is going to be, what open source GUI tools would you recommend for managing Postgres other than pgadmin?
On the open source world, I think pgadmin is by far the best. If you want more, if you want to do things like to understand performance gaps, read logs, find locks, etc., then please take a look at Postgres Enterprise Manager. I know that's not an open source tool, but I'm not aware of any open source tools that will take you beyond what pgadmin can do. Doesn't mean that there aren't any, but I just don't know them. And pgadmin is a tool that manages Postgres in like the current state of Postgres. But if you really want to understand, like, what happened this morning at 10:30? Why was the database slow? What locks suddenly occurred? I'm not aware of an open source tool doing that, but tools like PEM, Postgres Enterprise Manager, they do that. So take a look at that. As I said, it's not open source, but I don't have a good open source answer for you.
All right. Thank you again, Mark, for the presentation and answering these questions. I apologize for those questions that we are unable to get to today, but they will be shared. We will be giving the answers to anyone who asked. Thank you all for joining us for the webinar. We will be sharing this recording along with the slides with you as soon as possible, and I hope you have a great rest of your day. Bye.